Let's talk about electron configuration. At first glance, this looks kind of complicated. All of these numbers and letters and superscripts. Let me explain this notation. Electron configuration is simply a shorter way to write what we've been doing with boxes and arrows. This also shows all the positions of electrons in an atom, though it doesn't give quite as much detail. The larger number in this notation represents the energy level for an electron. So this number 3 that's highlighted tells us the electrons here are in energy level 3. The letter that I've highlighted, this tells us what kind of sublevel it is. Now remember, the type of sublevel determines how many electrons can be held within that sublevel. So a p sublevel, for example, has a maximum capacity of 6 electrons. And that leads us to the third part of this notation, the exponent. The exponent tells us how many electrons are in that sublevel. When we read electron configuration, we don't actually read it like it were an exponent. We don't read this as 1s squared, 2s squared, 2p to the 6th. We simply read it 1s2, 2s2, 2p6. Now, let's review the capacity for each sublevel. If we are writing in electrons in an s sublevel, the maximum number of electrons would be 2. However, if we're using a p sublevel, this can hold 6 electrons. How many electrons fit into a d sublevel? There are 10. And finally, the f sublevel, that holds 14. Let's try an electron configuration now for magnesium. When you do the electron configuration for magnesium, first you want to identify how many electrons there are. This is element number 12, which means it has 12 protons and 12 electrons. I'm going to write this down, magnesium, which has 12 protons and electrons. And this time, instead of drawing boxes and filling in arrows, I'm going to simply write 1s, 2, 2s, 2, 2p, 6. Remember, these numbers I'm writing in superscript up here tell how many electrons there are. So I've represented 10 electrons so far. There are still 2 electrons that remain. I wonder where those electrons will end up. What is the next sublevel after you've filled up the 2p? The next sublevel is the 3s, and we're going to put 2 more electrons there. There's a real easy way to check if we did this right. We're simply going to add up all of these numbers up top and see if they don't add up to the number of electrons. And in this case, they do. Let's try our next example. We're going to write the electron configuration for sulfur. The periodic table shows sulfur over here with 16 electrons. So I write down the symbol for sulfur with the number 16 so that I know what I'm drawing. And then I begin with a 1s2, 2s2, 2p6. I'm going to keep writing until I get 16 electrons, so that's 10 so far. This gives me 2 more, that's 12. And in the 2p, I will not need to fill up this sublevel. I only need 4 more electrons to make 16. Again, if we add up all of these numbers up here, we'll find out that they make 16. We have correctly represented the electrons in a sulfur atom. One more example. Let's try the electron configuration for a silver atom. Recall that the element symbol for silver is Ag. That is right here, and silver has 47 electrons. Here are the electrons in a silver atom. Now let's do a quick check, make sure that these numbers work out. I'm going to add up each of the superscript numbers here and make sure that they all add up to 47. And it looks like they do. So this is how we're going to show electrons around an atom, either with electron configuration, which is a little shorter, or with orbital diagrams, which involves drawing boxes and filling in arrows. Make sure you watch the next video too, because I've got some great shortcuts to make this even more fun and easy.